Okay, thanks very much. First, let me start by thanking Ahern and Jim for organizing the conference again and for asking me to participate. I like this paper a lot, so let me jump right in and tell you what I think the paper is doing. I'm going to focus mainly on that middle part of the paper, the randomized experiment, because I think that's the most credible part of the paper, the most interesting part. And out of that part, there are two main results that I take away from the paper. The first is that on this online crowdsourced platform, when estimized users forecast without seeing the consensus, they have different estimates, and then when they see the consensus, they revise their estimate towards the consensus. Okay, why does that matter? This is consistent with herding or peer effects. And the second main result is that the blind consensus is more accurate than the revised consensus. Why does that matter? Well, this is consistent with information blockage, meaning that these people have private information that's not getting incorporated into the consensus. Okay, so what I want to do in my comments is try to say what we can interpret from these results and what we can't, and then talk about generalizability. Anytime you have a field experiment, you might worry about, does this extend beyond this special setting? Okay, so there are a lot of papers on herding. There are a lot of papers on herding among analysts. So here's the sample going back to 1999. There's herding in analysts' earnings forecasts, herding among security analysts, herding of earnings forecasts, following the leader, herding behavior, who herds, do analysts herd? You would think by now we might know this, right? So the question is, do we need another paper? And I think we do, actually, because most of these papers are just showing correlations. They're showing that when two analysts seem to, they show two analysts are providing estimates that look similar, and they're arguing that that's herding. But we're not really sure that that's the case. So we want to think about that. This is a very challenging empirical exercise to identify a causal effect of herding. Charles Mansky is a guy who's written a lot about this, and he says there are three main reasons why you might see two people who have the same kind of result. So observe mimicry. The first is what he calls an endogenous peer action. This is where the peer's action causes the individual's action. And this gets a feedback effect, because if the peer group influences my action and I revise my forecast up, then all the peers will see my action and they'll revise their forecast up. Okay? And that's what makes it endogenous, that there's this feedback effect. That's very important. The second type is what's called a contextual peer effect. This says that I'm not responding to the actual action. I'm responding to some trait that's correlated with the action. So for instance, my forecast might be high because the peers are young, and the young tend to have high forecasts. And this is different because if you somehow manipulate the forecast of these people and increase it, I'm not necessarily going to change my forecast, because really what I'm responding to are their traits. And since you didn't change the fact that they're young, I'm not going to change my forecast. This has the difference between contextual and endogenous makes a big difference in policy implications. If you want to change behavior of people, the first one's a lot easier to do it. Okay, and then the third one is correlated effects. This is the common omitted variable problem, where the same common traits influence both the peer's action and the individual's actions. Okay, that is not a peer effect. So in that case, you would have my forecast is high because both the peers and I are young. Now, most of the prior literature, I would argue, was just showing this. They show that one analyst puts a high forecast, and then another one who follows them afterwards has a high forecast. But we're not really sure what's causing that. What this paper is doing is showing one of these two. Now, we don't know which of these two it is, because we can't separate out the endogenous from the contextual, and that's actually very typical. It's very hard to separate those out. And in particular, in this case, the estimized users, all they see is nothing or the forecast. So we don't see a change in the forecast that they respond to. They just see nothing, and then they see the consensus. So when they respond to that consensus, they could be responding to the height of that consensus, what the level of that consensus is, or they could just be saying, okay, these are my peers, I want to look like them. But it might be their traits, not the actual forecast. Either way, it's a contribution over what's been done in the past. It is a causal peer effect. So, okay, so novel contribution, right? Oh, God, not so fast. So if you go back, I showed you those papers from 1999. There's actually a paper in 1997 by these two people out of Washington State, and you notice it was in Behavioral Research and Accounting. Probably not a journal you might have heard of, but in fact, this paper was doing the same thing that this paper does, just in 1997. And So let me show you real quick what it's doing. So in 1997, we didn't have online platforms, but what we had were National Association of Investment Clubs. So these researchers went and talked to these clubs and said, basically ran the same experiment where they said, well, first of all, these clubs are similar to Estimized users in that they include professionals, but they also include students and regular people. So they are not completely uneducated. They're people who have some skill in this. And they would go to them and say, all right, here's the information on the company. Come up with your estimate. They did that. And then they showed them 3 different forecasts or 3 different consensus and said, would you like to revise your consensus? Which is what they did in this paper. It's a great design. What was different about that 97 paper is that they showed them they randomized whether consensus that they showed them was high, middle, or low. That was beneficial because then it separates whether I just always revise my estimate upwards as opposed to I revise my estimate towards the consensus. But either way, they find the same thing. Now, I don't blame the authors in some sense. One of those 9 papers that I cited before, only one of them cited this paper. So it's kind of ironic, in fact, that a paper on herding is lost in this uninformative cascade, which I think happens a lot, right? So they didn't cite it, so I'm not going to cite it. But I think in some sense, this 97 paper, if it was around today, it would be published in a top journal. We just weren't really ready for it at that time. All right, so the second point is, what is this paper, what type of peer effect is this, what type of social interaction is this paper identifying? So again, going back to Charles Mansky, he talks about 3 types of social interactions. He argues that all of economics is about social interactions. The first one is what he calls constrained interactions. This is where one person uses a resource, so that resource isn't available to someone else. That's just supply and demand, basically. Classical economics. The second is what he calls expectations constraints. This is where I learn from somebody else, and that influences my choices. This is the classic Bikhchandani et al. Information cascade story. And then the third is what we typically call behavioral stories. These are preference interactions, where my preferences depend on other people's choices. So conformity, jealousy, envy, so on. Those are in that type of social interactions. So the question is, which one is this paper picking up? It wants to talk about the second one, but we're really not sure. It's not sure if it's the second or the third one. We don't know if people are responding to the information or to the preferences. So let me show you another paper that has a design that can separate those things so you can see if they wanted to revise this, how they might do it. So there's this other paper in Econometrica a couple years ago. This was an investment field experiment where they were given a choice to make an investment in a peer group. So let me just explain what they did. So they randomized, they asked people if you want to make the investment. And then they randomized whether you would actually get to make the investment or not. So they now have the difference between the information of wanting to do something and then actually getting the investment, the good. And then they told the peers, well, this guy, your peer, wanted to make the investment but didn't get it, or he wanted to get it and he got it. And then they asked, how would you want to make your investment? And what this does is it separates whether I'm responding to the information. Do I want to buy this investment because I learned that it's a good investment? Or do I want to buy it just because I want to look like that guy? That's the conformity story. So in that case, you can see you separate them. So in the current paper, Xing's paper, we can't actually tell which one it is. It's okay, but it's a way to think about the future, how you might want to differentiate between these two. All right, so then the main result, I think the first result has somewhat been done before. The second result is the one that I think is the most interesting, that the blind consensus is more accurate than the revised consensus, and that's related to my last point. So, okay, the last point is about the generalizability of this. We might say, who cares about this? This is a bunch of weird people who go online, spend a lot of time, and put up their forecasts for what? Why are they doing this? They get a ranking on a league table. Some of them might be doing it for reputation concerns, but some of them clearly aren't because they're anonymized. They don't put their name there. Some of them are students. Some of them are, they're all different types of people. So we want to understand what are the incentives of these people. Okay, so if we want to try and understand the incentives of these people, we might think this is weird. But we might also think this is actually not that uncommon. So if you think about all these other open source things like Wikipedia or R or LaTeX or Linux where people write code and upload it for free to other people, they have the same kind of incentives that are going on. So we don't know what those incentives are, but they're important because this is not something that is uncommon. Or you might think about this. Why do people write referee reports or do conference discussions or contribute in seminars? Right? We're not getting paid. but we're still contributing our information. We have incentives to do it. We might think about reciprocity, but they're not pecuniary incentives. Or you might think about this, right? You can go to Amazon and look up ketchup, and there's 200 people who gave the review of ketchup. And if you have a question about it, there's 5 questions that have been answered, okay? So basically, you can find anything that you want to review on. People have contributed without obvious incentives to do so. So here, you can even find this conference on Yelp. Look, there's the Utah Winter Finance Conference. I don't know if you can see, you can't see the picture, but Adriano's there. But look, Ralph has a comment. It says, great skiing, great people, and great discussion about endogeneity. Mark Grimblatt, pretty relaxed, except that one loudmouth with the funny accent. I don't know who he's talking about. And then that one is Ahern. I don't know if you can tell. It says, easily the best organized finance conference. I don't know how they do it year after year. Okay, so there might be a little bias in some of these. But the point is that this is not uncommon, actually. This is what might seem like a limitation of this study, I think is actually one of the best things about this study, is it's looking at something that is common, is being done all the time. I think it's very interesting to think about this. The founder of Wikipedia says one of his inspirations for founding Wikipedia was this very classic article by Hayek, The Use of Knowledge in Society, which says centralized authority can never make as good a decisions as decentralized because they don't have all the information. So how do you get all the information? You have a private market. That was a revelation at that time. And this is the guy who founded Wikipedia said, all these people have information. How do I create an encyclopedia? I want to collect all the information. But what's interesting is that he didn't get the part about the market, I guess, because there is no market there, or the way we typically think about it. So even though we know a lot in finance about efficiency of financial markets and markets in general, we might want to think about other ways that information is getting aggregated, because it is happening in other ways. And as this paper is showing, even when they don't have the incentives that we think of, they're more accurate than having a traditional market. Okay, so what I think they might want to think about is the mechanism design problem here. You mentioned a little bit about it, but there's a paper by Ilan Kremer et al., which is saying, how do I elicit this information when they have incentives that are not based on prices? Okay, so since you're able to work with SMIs, maybe you can get them to revise this to give them different ways to figure out how to elicit better information. All right, so let me just summarize. I think it's an excellent paper. I think it sets a high standard for us. This field experiment is really nice. There's a lot to explore, and so my forecast is that I think it'll be a top journal publication. All right, thank you.